Okay, good afternoon, everyone. So this is in today's lecture, we're going to discuss section 3.2, that is about the derivative as a function. Now, when we look at the derivative as a function, I defined the derivative in last lecture, and the derivative was defined as the limit of this difference quotient. F prime of x is equal to limit h goes to 0 of f of x plus h minus f of x divided by h. Now, if you notice, x can vary, right? X can take on variable values, and this actually defines a new function. And for each x, f prime of x gives a slope of the tangent line to y is equal to f of x, the graph of this function, at this given point. So I'll give you an example. When you look at this function here, right? You draw this function, okay? You think, okay, going along this is a roller coaster. Think about the slope as you're going along the roller coaster. Is it a steep slope? Are you going up on your roller coaster? Or are you going down? If you're, say, at the top, right before you go down on this large decline on the roller coaster, right, you usually sort of stay at one place. And it's approximately like here. The horizontal tangent line means zero slope. So here's our function. We're going to graph y is equal to f prime of x by looking at what the slope is at each point. Now let's first recognize it's usually pretty straightforward to recognize where the slope is 0. That means that what you have is usually it's going to look like a hill or a valley, or maybe something sort of in between the hill and the valley. In this case, let's bring all these points down. So this point corresponds to this point here. So the horizontal tangent line in the graph of the original function means a value of 0 for the graph of the derivative. The horizontal tangent line on the graph of the original function, again, means the value of the derivative is 0. Something here. Okay, so whatever the graph of the derivative is, it has to pass through these 3 points on the x-axis. It has to have these 3 points as x-intercepts. Now let's look here. What happens initially? Okay, it does have slope that's initially 0. The function, what's happening at the slope's here? Well, look, they are negative. And they're actually negative because the function is decreasing. So I'll go over the rules for that in a second. So it is negative, but then it goes back up to being 0, right? Here, what happens to the derivative? Well, it's steep, but the function's increasing, so now it's positive. Until what? Until it reaches here. It's going to start being negative right after this second x-intercept. Now the derivative is negative here. And again, after this, the last point on the graph of the original function where the tangent line had 0 slope, the function remains increasing, its slope is positive, and keeps getting steadily steeper and steeper. So again, we can just analyze the function by analyzing its slope. So all this is saying, okay, here's the graph of the function, here's the graph of the slopes.